Okay, maybe it was a little cavalier of me to say that you are going to remember that number 2 and its implications. Maybe you remember this, though. When I say standard error, you might remember something else that starts with standard. You might remember standard deviation. That's something we studied, I think, a week before the central limit theorem, right? Standard deviation. What that was that was the average distance all the data points are from the average in a sample distribution. We weren't trying to do anything fancy back then. We were just simply collecting data and then looking at the graph, and sometimes it looked like a bell curve. Bell curve. Sometimes it looked like a bell curve. And we talked about bell curves are one of the few times you can actually trust the standard deviation because of that symmetry in the shape. So when you have an average in a bell curve, you can trust the standard deviations around that average because there's no skew pulling the average one way or the other. Fortunately, we get bell curves in sampling distributions. You saw that last week, remember? As we sampled from size 4 up to size 9, up to size 16, those bells started really showing up. The tails started pinching down, the middle started getting larger. So where does the 2 come from? Okay, we're going to tie 2 things together here. We mentioned at the end of yesterday's playlist of videos, 95% confidence. 95%. Man, 95%. That percentage was around when we talked about standard deviations. It was the percent of data that was within 2 standard deviations of the average. If you look at this bell curve right here and go out 2 standard deviations, 95% of the data in that graph is between the 2 standard deviations. Well, guess what? In a sampling distribution, 95% of all possible sample averages are going to fall within 2 standard errors of the average of that distribution. So the reason I used that 2 SE, 2 times the standard error, for the margin of error, was because I was leaning back on that idea of 2 standard deviations trap 95% of the data. So when you hear about the idea of 95% confidence, it's bleeding into inferential statistics right here. 95% confidence utilizes 2 standard errors in the calculation. We're going to see this again more in the actual calculation of the margin of error we do starting next week with sample proportions and then sample averages the week after that. But that 2 stands for 95%.